नमस्कार दोस्तों, हमारे चैनल पे ब्लैक में आप सभी का स्वागत है। आज हम पढ़ाने हैं कुछ इंपॉर्टेंट सॉलिड स्टेट मॉलिक्यूलर टाइप्स ऑफ सॉलिड constituent particle bonding attractive force, for example physical nature, electrical conductivity, melting point. First, molecular solids non-polar polar hydrogen bond molecules dispersion or London force and dipole dipole interaction hydrogen bonding ArCl2 H2I2 CO2 HCl SO2 H2O soft hard insulator very low ionic solids ions Coulombic electrostatic gradient Cl MgO CF2 hard but brittle insulators in solid state but in molten state and in aqueous solution high. Third, metallic solids positive ion in a sea of lead electron metallic bonding ferrous copper silver magnesium hard was malleable and ductile conductors in solid state as well as in state barely high. Covalent are network solids atoms covalent bonding SiO2 quad C diamond Al3 hard soft 2 liter conductor exception very high. Cube tetragonal orthorhombic hexagonal rhombohedral monoclinic triclinic. Primitive or simple body centered face centered primitive body centered primitive end centered body centered face centered primitive end centered. Types of Monte stoichiometric defect interstitial defect Frankel defect Schottky defect Frankel defect देखिए दोस्तों introduction of cation by combination substitution of Na plus and by Sr2 plus. Types of solution solute solvents common example general solution gas liquid solid gas solvent mixture of oxygen and nitrogen gas chloroform mixed with nitrogen gas camphor and nitrogen gas liquid solution gas liquid solid liquid oxygen dissolved in water ethanol dissolved in water glucose dissolved in water solid solution gas liquid solid solution of palladium amalgam of mercury with sodium copper dissolved in gold. Calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2 by mass. Molar mass of C2H6O2 12 into 2 plus 1 into 6 plus 16 into 2 equal to 62 gram mole inverse. Moles of C2H6O2 barabar 20 gram upon 62 gram mole inverse equal to 0.322 mole. Moles of water 80 gram upon 18 gram mole inverse 4.444 mole. X glycol equal to moles of C2H6O2 plus mu upon moles of C2H6O2 plus moles of H2O 0.322 mole upon 0.322 plus 4.444 mole equal to 0.068. Similarly, X water equal to 4.444 mole upon 0.322 mole plus 4.444 mole equal to 0.932 mole. Fraction of water can be calculated 1 minus 0.068 equal to 0.3. Calculate the molarity of a solution containing 5 gram of NaOH in 450 ml solution. Moles of NaOH 5 gram per 40 gram mole inverse equal to 0.125 mole. Value of solution in liters equal to 450 ml upon 1000 ml liter inverse. Molarity equal to 0.125 mole into 1000 ml liter inverse upon 450 ml. 0.278 0.27 mole liter inverse 0.278 mole dm minus q. Calculate the molarity of 0.5 gram of ethanoic acid and 75 gram of benzene. Molar mass of C2H4O2 is equal to 12 into 2 plus 1 into 4 16 into 2 equal to 60 gram mole inverse. Moles of C2H4O2 5 gram 160 gram mole inverse 0.417 mole. Mass of benzene in kilogram equal to 75 gram upon 1000 gram kilogram 75 into 10 power minus 6 kilogram. Molarity of C2H4O2 moles of C2H4O2 upon kilogram of benzene equal to 0.0417 into 1000 gram kilogram upon 75 gram 0.5556 mole kilogram inverse. Calculate the mass percentage of benzene C6H12 and carbon tetrachloride. If 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride Second, calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. Third, calculate the molality of each of the following solutions. First, 30 gram of CuNO3 का whole to the R 6H2 and 4.3 liter of solution B 30 ml of 0.5 m H2 support diluted to 500 ml. Calculate the mass of urea and H2CO and H2 required in making 2 kilogram of 0.25 molar aqueous solution. Fifth, calculate molality and molality is mole fraction of Ki if the density of 20% mass by mass aqueous Ki is 1.202 gram milliliter inverse. Vapor pressure of chloroform and dichloromethane CH2Cl2 at 298 Kelvin or 200 mmHg and 415 mmHg respectively. Calculate the vapor pressure of the solution prepared by mixing to 125.5 gram of CaCl3 and 40 gram of CH2Cl2 at 298 Kelvin and reactions of each component in vapor. Molar mass of 2CH2Cl2 equal 12 into 1 plus 1 into 2 into plus 35.5 into 2 equal to 85 gram mole in 1. Mass of CH3 12 into 1 plus 1 into 1 equal plus 35.5 3 equal to 119.5 gram mole in 1. Moles of CH2Cl2 equal to 40 gram upon 85 gram mole in 1 0.47 moles of CHCl3 25 gram upon 119.5 gram mole in 1 0.213. Total number of moles equal to 0.47 plus 0.213 equal to 0.683 mole XH2 CH2Cl2 0.47 mole upon 0.683 equal to 0.6883 x CHCl3 1 minus 0.688 equal to 0.312. Equation 2.1 P total equal to P1 naught plus P2 naught minus P1 X2 equal to 200 plus 450 minus 200 into 0.688 equal to 200 plus 147.9 equal to 347.9 mmHg. Using the relation 2 y1 is equal to pi upon p total, we can calculate the mole fraction of a component in gas HP CH2Cl2 688 into 450 mmHg equal to 285.5 mmHg. P CHCl3 equal to 0.312 into 200 mmHg equal to 62.4 mmHg. Y CH2Cl2 equal to 285.5 mmHg upon 347.9 mmHg 0.82. Y CHCl3 equal to 62.4 mmHg upon 347 mmHg equal to 0.18. Gram of glucose is CH12 dissolved in 1 kilogram of the water in a saucepan. At what temperature will water boil? At 1.013 bar kV per water, 0.52 kilo moles of glucose equal to 80 gram upon 180 gram mole liter. Mole inverse equal to 0.14 1 mole. Number of kilogram of carbon equal to 1 kilogram. Delta glucose solution equal to 0.1 mole kilogram inverse part water change in boiled. Delta TV is equal to kb into m equal to 0.52 kilogram mole inverse into 0.1 mole kilogram inverse equal to 0.052 kilo. Since water by the 75.15 Kelvin at 1.13 bar pressure, therefore the boiling point of solution will be 53.15 plus 0.052 equal to 375 3.202. The boiling point of benzene is 353.23 and 1.80 gram of non-volatile solute was dissolved in 90 gram of benzene. The boiling point is rated 54.1111 K. Even calculate the molar mass of solute Kb for benzene is I kilogram mole inverse. Elevation in boiling point 354.11 minus 350.2 equal to 0.088. Substituting the given in expression 2.33 we get empty equal to 2 kilogram mole inverse into 1.8 gram into 1000 gram kilogram inverse upon 0.88 kilo into 90 equal to 58 gram mole inverse. Molar mass of solute equal to 58 gram mole inverse. 45 gram of ethylene glycol is mixed with 600 gram of water. Calculate freezing point depression and the freezing point of the mole solution. Depression and freezing point is related to molarity. Therefore, the molarity of solution with respect to ethylene glycol moles of ethylene glycol mole upon mass of water in kilogram. Moles of ethylene glycol equal to 45 gram upon 62 gram mole inverse equal to 0.73 mole. Mass of water in kilogram equal to 600 Kelvin. upon 1000 gram kilogram inverse 0.6 kilogram. Its molality of glycol liquid 0.73 mole upon 0.60 kilogram 1.2 mole kilogram inverse. The freezing point equal to delta TF is equal to 1.83 kilogram mole inverse into 1.2 kilogram inverse equal to 2.2. Freezing point of aqueous solution equal to 73.15 Kelvin minus 2.2 equal to 75.95 Kelvin. 1 gram of non-electrolyte solution dissolved in 50 gram of benzene lowered by freezing point of benzene by 0.40. Freezing point depression constant of benzene is 5.12 kilogram per molar mass of the solute. Substituting the value of various terms involved in 2.3, we get dm is equal to 5.12 kilogram mole inverse into 1.00 gram into 1000 gram kilogram inverse upon 0.40 into 50 gram is equal to 256 gram mole inverse. Thus molar mass of solute equal to 256 gram mole inverse. 200 centimeter cube of an aqueous solution of protein containing 0.26 gram of the protein. The osmotic pressure of such a solution at 300 kPa is found to be 2.57 into 10 power minus 3 bar. Calculate the molar mass of proteins. The various quantities known to us are as follows: pi equal to 2.57 into 10 power minus 7 bar, b equal to 200 centimeter, v equal to 0.200 liter, t equal to 300 Kelvin, r equal to 0.083 liter bar per Kelvin. Substituting this value in equation 2.42 to get the m2 equal to 1.26 into 0.83 liter bar Kelvin mole inverse into 300 Kelvin upon 2.57 into 3 bar into 0.20 liter equal to 61.022 gram mole inverse. Vapor pressure of pure water at 298 Kelvin is 23.8 mHg. 50 gram of urea is dissolved in 150 gram of water. Calculate the vapor pressure of water for this solution. It is relative lowering. The boiling point of water at 750 mmHg 99.63. How much sucrose is to be added to 500 gram of water such that it boils at 100 degrees Celsius? Calculate the mass of ascorbic acid to be dissolved in 75 gram of acetic acid to lower its melting point by 1.5 degrees Celsius. Kf equal to 3.9 kg mole inverse. Calculate the osmotic pressure in pascals exerted by a solution prepared dissolving 1.0 gram of polymer of molar mass 185,000 in 580 ml of water at 37. 2 gram of benzoic acid dissolved in 25 gram of benzene shows a depression in freezing point equal to 1.62 Kelvin. Molar depression constant of our benzene is 4.9 Kelvin kilomole. Now molar, what is the percentage association of acid formed with diabatic solution? W2 equal to 2 gram, Kf equal to 4.9 kilo mole, and W1 equal to 25 gram, delta T equal to 1.62 Kelvin, M2 equal to 0.9 kilogram mole inverse into 2 gram into 1000 gram kilogram inverse 1.5 gram into 1.62 Kelvin equal to 241.98 gram mole inverse. The experimental molar mass of benzoic acid in benzene is 41.98 gram mole inverse. Now consider the following equilibrium for the C2C6H5COOH reversible C6H5COOH covered by the experiment degree of dissolution of solute, then we would have 6 mole of benzoic acid left in unassociated form and correspondingly X by 2 as associated moles of benzoic acid at equilibrium. Therefore, total number of moles of particles at equilibrium is 1 minus x plus x by 2 equal to 1 minus x by 2. The total number of particles at equilibrium is equal to 1 half factor I equal to normal molar mass upon abnormal 122 gram mole inverse upon 241.898 gram mole inverse. X by 2 equal to 1 minus 1 T2 upon 241.98 equal to 1 minus 0.504 equal to 0.46. X is equal to 2 into 0.496 equal to 0.992. 0.6 ml of acetic acid have density 1.06 gram mole in milliliter inverse is dissolved in 1 liter of water. The depression in freezing point observed for this strength of acid was 0.0205. Calculate the 1.5 factor and deterioration constant of the acid. Number of moles of acetic acid 0.6 ml into 1.06 gram mole liter inverse upon 60 gram mole inverse to 0.0106 mole equal to 2 and molality equal to 0.106 mole upon 1000 ml into 1 gram mole milliliter inverse equal to 0.0106 mole kilogram inverse. Equation 2.7 delta DF equal to 1.836 kilogram mole inverse into 0.016 mole kilogram inverse 0.0197 Kelvin band half factor equal to absolute freezing point upon calculated freezing point 0.204 upon 0.0197 Kelvin Kelvin to 1.041 CH3 C double H benzene H plus CH3 C double O N 0 N 1 minus NF the total moles of particle are N1 minus X plus X equal to N1 plus X I equal to N plus X 1 N equal to 1 plus X 041 CS3 0 N1 minus X 0.01 061 minus 0.04 CS3 NX equal to 0.016 into 0.041 H plus equal to NX 0.016 into 0.041 K A equal to CS3 COOH upon CS3 0.016 0.041 into 0.0106 into 0.041 0.016 0.00 minus 0.041 1.8 minus 5 धन्यवाद दोस्तों चैनल को लाइक सब्सक्राइब करना मत भूलिए धन्यवाद दोस्तों।